In this video, we're going to talk about multiplying and dividing rational expressions. What that means is we're going to be multiplying fractions that happen to have x's on the bottom. So to give you context from what you've already had experience with, in elementary school, when you multiplied fractions, you multiplied straight across. So you multiplied numerator times numerator, denominator times denominator, and then you simplified. Now, there are some tricks that you could have done along the way to help simplify the question in the process, but you may not have necessarily done that. I'm going to do it every problem using the long way, meaning I simplified the very end. Okay? Now, my examples come from page 12 of the fall packet from 2021, if you're not watching it, relative to that date closely. So, here we go. Let's look at our first one. Okay, so this one has no adding or subtracting. It just has variables in it, okay? So this is number 1 off that page. So I have 2a squared times b over b squared c times b over a. Well, it's just a regular fraction times a fraction, so I can multiply straight across. All right, so when I did that, I added my exponents together. So b times b became b squared. And for the bottom, I just happened to move the a in front of the b squared. I didn't do anything special for that. But now that I have everything together as a single fraction, now I can begin to simplify. So the b squareds canceled, and a to the second means I have 2 a's up top. And so one of those a's canceled with the a on the bottom. So that leaves me a 2 and an a on top and a c on the bottom. So that's my final answer. Now, the next question that I want to talk about is one where there's more to it. There's actually plus and minus signs. This is where things get dangerous, because we cannot cancel if there's anything being added or subtracted outside of parentheses. Okay, we can only cancel groups when there's a plus or minus sign. So here we go. This is example 2. Okay. So one of the first things I did was I factored them. Okay, you always want to factor to start with if you can before you multiply. Now, once I have it factored, then I'm going to multiply straight across. Now, for simplicity, what I did was I moved this 8 out in front. Do you have to keep it there? Not necessarily. Could you start to cancel now if you really wanted to? Sure, of course you could. But I'm not going to. So here, I've multiplied straight across. I've rearranged things a little bit. But I've noticed that there's a y plus 3 on top and a y plus 3 on the bottom. That lets me cancel. Also, 4 goes into 8 2 times. So that's why I canceled. That's why I see the slash through the 4 and through the 8. And I put a 2 there in its place. So now that I've done that, I'm just going to clean this up a little bit. And that leaves me with 2 times y minus 5. And that's my final answer. Now, you might say, well, wait a minute, that's not even remotely complicated. Okay, give me something, that's more complex. So, I'm looking at number 7. Okay, in this problem, I have expression, 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 and then I have another one here. So what I'm going to do is I'm going to factor each of these. especially these two bottoms. And now I'm starting to see stuff that's likely going to cancel. But, like I said, I'm not going to cancel until after I've multiplied. So now I multiply straight across. So now in this next step is where I'm going to cancel these x plus 3s and I'm going to cancel these x plus 2s. And you'll see that just like that. But when I've done that, I just canceled everything up top. You have to remember, you can't leave the top empty. There has to be something in the numerator. So what happens when you divide something by itself? You get 1. So I'm going to put a 1 up top. And the denominator is just what's left over. But I promised you in this video that we would be talking about multiplying and dividing. So here is a couple dividing questions. Now, just like before, I'm going to start with a reference to elementary school. Okay, so let's just say I have this expression here. I have 5/8 divided by 2/3. Now, if you recall, when you divided fractions at elementary school, you did a process called multiply by the reciprocal. And to help you remember to do that, a lot of teachers came up with little funny sayings and what have you. But essentially what it is you need to change the sign of multiplication and flip the second fraction. Hence, a lot of teachers came up with keep, change, flip. It works. It's simple. It helps people remember. But after that, now you multiply straight across, and you would simplify if needed. Every fraction must be simplified. So here we go. Let's give you an example. So now I'm looking at example 3. Okay, a not too crazy example just yet, but I have x minus 5 over 6 divided by 2x minus 10 over 12. Now, you have the option. You could factor first and then keep, change, flip, or keep, change, flip, and then factor. Completely up to you. Doesn't matter. What you cannot do is multiply or simplify before you do that. So here we go. I decided to do the keep, change, flip first. And now you're going to see me factor. So now I've got the expressions broken down, especially this 2x minus 10. It's now an x minus 5. And remember, what we're looking for are for things to cancel. So x minus 5 and x minus 5. I know those are going to cancel. But I'm going to be patient here. So I'm going to multiply straight across. They gave me a 12x minus 5 on the top. 6 times 2 gives me a 12x minus 5 on the bottom. And darn it if the 12s don't cancel and the x minus 5s. So that whole original expression is equal to 1. Okay, everything canceled, so I have to have something, and it's not 0. So it's just 1. Now, of course, we're going to have more complicated scenarios like that. So here is one. This is number 6. Now in this instance, I have 2 trinomials, meaning there's 3 things being added or subtracted. And the worst case scenario would be you would have all 4, so you would need to factor all 4 of them. That's the worst it will get. So after recent experience with our practice factoring, hopefully that part's not too inconvenient. So what I'm going to do is I'm going to do my keep, change, flip first. Now, you might want to, but you cannot cancel these 8s. You cannot reduce the 8 to the 24 because this has a plus sign, that has a minus sign, and they're not in groups. So I'm going to keep change flip. Now that I've done that, now I'm going to factor all 4 of these. Now these 2 I'm going to break into groups. You know, what multiplies together to give me the last number, what adds together to give me my middle numbers, and then what can I take out of the 2 bottom expressions. And so that's what I have here. Now, again, if you want to start canceling things, you're welcome to do so. You could cancel up and down, you could cancel diagonally, but you cannot cancel left to right. So what I've done is I multiplied initially, but then I canceled. So I put all 4 of these factors up top. I multiplied by 2 and my 8 to get 16. And I brought the m plus 3 and the m minus 4 down here on the bottom. The m plus 3's canceled. The m minus 4's canceled. And I'm left with m plus 2 and m plus 4 on the top. I cannot combine these in any way. If I wanted to multiply them out, I could, but I'm choosing not to. Also, I cannot reduce this 4 with this 16 because this 4 is in a group, this 16 is not. You can only cancel groups. So I hope you found this helpful. I will see you guys next time.